Welcome back. We're going to cover section B today, and we're going to talk about a lot of the chemical and physical properties of the ocean water. Okay, we know it's salty, but it's a little more complicated than that. So let's talk about why it's salty. There's a couple of theories, and you know the old Earth, the non-creation scientists think that it just is salty strictly because of the minerals from erosion of the land being washed into the ocean. Creation scientists think that it was created salty first of all, but the flood made it even saltier, and that erosion of land and rock is continuing to add salt to it. Okay, so these rivers are bringing sediment, and they contain salt. So when we think of salt, we think of like the salty salt, right? But there's other salts when we talk about minerals, and a lot of those come in those sediments. Since rivers are constantly moving, they're constantly flushing out, and they're constantly being fed with new fresh water. They don't ever get salty. It's just that those sediments and those minerals then get deposited into the ocean to make them salty. So the ocean is about 3.5% salt, and that can change as the water evaporates. It gets more concentrated, so it's a higher concentration. As more rivers are dumping fresh water in, it gets less salty, less concentrated. But on average, the oceans are about 3.5% salt. Okay. The main salts, the main ones are the salt when we think about salt. We've got sodium and chloride, okay? So everything except that portion of the pie. So all of this, that's the main salt. The salt that you sprinkle on your food is sodium chloride, okay? So that's why it tastes so salty. But it also contains other things like magnesium and calcium and sulfate and calcium and all these different minerals that add to the salt content, okay? Don't worry about those amounts on here. They're slightly different than the amounts that they show in the book on page 317. Just kind of know that sodium and chlorine are the main salts of the ocean. There's also dissolved gases in the ocean water. There's dissolved carbon dioxide, there's dissolved oxygen and nitrogen. We'll talk about nitrogen a little bit later. The dissolved oxygen is what fish are able to absorb through their gills that allows them to breathe. Okay, that oxygen gets into their bloodstream from that. Okay. All right, so there's a lot of different things that can affect the salinity. And the oceans are gradually getting saltier. Like I said, we're going to talk about the water cycle eventually, and we're going to talk about what it means for the water to evaporate away. But then it rains and the river comes in. So it's a very slow process, but that sediment is constantly being fed into the ocean. And so there's more sediment. Again, the minerals are added and the water evaporates off. If the water just evaporates off but doesn't get added, then it gets if the water evaporates off but doesn't get added, then it gets really concentrated. It would really increase the salinity. But since there is water continuing to be added, it's fairly stable. Those minerals are useful. Okay, a lot of animals use them to make their shells, and so the coral that we talked about in the previous section, they pull some of those salts out. Seashells are made of calcium and a mixture of those minerals. Okay. Sometimes a sea or an ocean region can be so concentrated that it forms this thing known as a precipitate. And so what happens is, if you pour salt into a glass of water, you can only put so much salt in it before it stops dissolving. Okay, water can only hold so much salt. It can only dissolve so much salt. And so if that concentration goes up too high, it starts coming back out of that solution and becoming a solid. So this is a picture right here of the Dead Sea. It's so salty. It has such a high concentration that the salt causes that precipitate, and this is literally like solid salt on the banks of this Dead Sea. Okay. We've got two vocab words. We've got brackish and brine. Brackish is the term used for the water near the mouth of a river. Okay, and it's not quite as salty as the rest of the ocean. So since the fresh water is dumping in, it dilutes it a little bit, and that's just known as brackish water, slightly lower salinity. Okay. Brine is what's left behind when seawater freezes, okay? And so when the seawater freezes, it leaves the salt. And so the ice is fresh water, okay? And so the seawater surrounding those icebergs or glaciers or whatever is much saltier than usual because that salt gets left behind as the water freezes, and that's known as brine, okay? All right, let's talk about some physical properties, the temperature of the ocean. This should make sense. This is a surface temperature map right here. You don't have to worry about the numbers, but the red colors are warmer than the blue and purple numbers, okay? So we've got the equator that runs right along there. That's the warmest region of the planet, so it stands to reason that that's where the warmest water would be. We've got the poles, and that's the coldest. That's the polar oceans up and down there, okay? The surface water totally depends on the sunlight, and that's why we have that. That's the amount of sun you get at the equator is much more than the amount of sun you get at the poles because of the angle of the sun, okay? As you get deeper, the water gets colder no matter where you are, okay? And then there's currents that kind of stir this up a little bit. But surface water, surface temperature, very much similar to the regional temperatures in the climate. As you get deeper, it's just cold, okay? The melting and freezing points. Fresh water has a melting or freezing point, it depends on if you're warming it up or cooling it down, of 0 degrees Celsius, okay? So if I cool water down to 0 degrees Celsius, it will freeze. If I heat up an ice cube, it will melt at 0 degrees Celsius, okay? But salt water needs an even lower temperature to freeze. It actually needs to go below 0. So minus 1.8 degrees is when salt water freezes. And remember, it dumps that salt out. This is why if you live in areas where it snows a lot or the road freezes, there's ice, they'll sprinkle salt on it because it keeps the snow from melting and causing too much ice. Or it prevents it from freezing as easily. That's what it is. So it prevents ice from building up on the roads. That's what the salt does. See, I live in Southern California. What do I know? Pressure. We are up on the surface and we've got this air pressure pushing down on us. But you've experienced water pressure. If you've ever tried to dive down to the bottom of your pool and touch the drain or whatever, you might feel a little pressure on your ears. If you're wearing goggles, you can feel it kind of pushing on your face. That's because all the weight of the water on top of you is pushing a pressure on you. So when I'm at sea level, the air pressure is called 1 atmosphere. That's normal air pressure, okay? Every 10 meters you go down into the ocean, so every 10 meters of depth, it increases about 1 atmosphere, okay? And there's a section on that. You're going to have a question on that that helps you kind of not really calculate, but kind of figure out how to determine what the pressure would be the farther you go. And that would be on page 322. This is why we physically can't dive too deep because the pressure would be too great. It would hurt our bodies, okay? Density. Seawater is denser than fresh water, okay? It's easier to float on salt water than it is on fresh water because it's denser, okay? If you've ever seen pictures of Salt Lake in Utah or that Dead Sea that I showed you on the other page, people will just lay out there and they just float on it because the water is so much denser than fresh water. It's very easy for the human body to float on it, okay? And then finally, the speed of sound. This has a lot to do with animals and how they communicate with each other through echolocation or whales and dolphins talking to each other. On average, speed of sound can travel about 4.5 times faster in the water than it does in the air. And so this allows sound. You might not be able to hear it as well, but it's going to travel very well through the water. Okay, that is it. Bye-bye.